Hi, my name is Akshay.
Hi, my name is Sean.
Hi, my name is Sarwood.
My name is Andrew, and this is our robotic gym spotter project.
In order to begin the project, the team needed to gain full understanding of the project, client needs, and design requirements. In the initial project outline, the initial information were mentioned in a generalized manner, which made it hard to understand exact client design requirements and specifications. To overcome that, the team have attended a first client meeting to gain full understanding of the client needs and the purpose of the project and its criteria. Doing so, the team gained better understanding of the project goals and client design requirements. This allowed the team to highlight and create appropriate project scope and design requirements to be evaluated and begin to work on to achieve and be implemented on the project. After the client's initial meeting, the team sat down to investigate and research the project design requirements and solutions to fulfill client needs. The team decided to use project understanding tools learned from the MMD subject. The 2x2 matrix was a very useful tool as it allowed the team to visually highlight the relationship between the different elements of the project. To gain further clear understanding of the project requirements, the team used the QFD Quality Function Deployment tool. The QFD highlighted all the important client requirements and the required engineering tools and elements to satisfy the project elements. That provided the team with insights to evaluate and prioritize these requirements according to their importance to the project. As a result, it was found that the most important element is safety. The team created a full tree diagram understanding tool to seek the best design and engineering tools that can be used to fulfill the design requirements and goals. To make sure that the team had a full understanding of the project and its needs, the team set up another meeting with the client to present the project scope, design requirements created by us to gain feedback towards seeking full client requirements understanding of the project needs.
During our meeting with Carl and Clyde, we were told to provide them with a few deliverables by the end of the semester. These were to provide several design concepts that can be adapted and used in general gyms with power gauges. Hence, restrict the designs to the design parameters. Also, 3D models of each concept were generated through computer-aided design software such as SolidWorks, and small-scale showcase functioning prototypes were also to be provided to allow the clients a clearer image of each idea. Finally, a detailed portfolio that highlights all the work that we have put in towards the project should also be delivered. Once our deliverables were understood, we then formed a list of all the tasks to complete until our client delivery on the 18th of June. From this list, we formed a Gantt chart that ensured us to be on track of our progress and not fall behind schedule. During the meeting, the clients told us about their problem in detail. We understood that gym users who were training alone with basically hardly any to no supervision, such as in 24/7 gyms, don't feel safe and find difficulty in lifting heavy free weights, specifically in the squat and bench press exercises. Additionally, we determined that we need to create a mechanism that can be adapted to standard power gauges in gyms and provide mechanical assistance to the user performing various exercises, such as bench pressing or squatting within the power gauge. This mechanism, in fact, will not obstruct the user performing exercises, yet only provide mechanical assistance when the user requires it and prevent the barbells, free weights from collapsing onto the user. There are 6 main design parameters that our prototypes will be constricted to. These are tracking, intuitive design, hindrance, workspace, modularity, safety. After determining the design parameters, the evaluation criteria was then set. Force application. The machine should only apply a small force directly upwards in the Z direction to help the user lift the bar when required. Analyzed from calculations, we determined that the machine needs to exert a total of 147.15 newtons when 20 kilograms of weight is added onto the bar that is 10 kilograms.
After finalizing design requirements, we started ideation process. Brainstorming took place so we could get all our ideas out in open and record them before any evaluation was made. We did this brainstorming in 4 phases. First, we started determining the subcomponent categories, then individually bringing forward ideas for each component, then adding them to the T diagram, and then moving on to the process of mixing ideas using morphological chart.
My initial design concept utilized the concept of a rack and pinion gear, where 2 independently driven motors can vertically pull up or down a barbell held within 2 independent barbell clamps, as shown in orange and yellow. Sensors will track the bar and activate the motors when the user is struggling to lift the barbell up. So during the design process, Akshay and we made 2 similar prototypes where we formulated those into one. The model shown resembles this combination, where 2 arm features shown in white shadow the barbell, allowing the user to experience 2 degrees of freedom, hence maneuverability or comfortability during an exercise. Sensors will track the position of the bar and inform 2 independently driven motors to reel up the arm parts when required.
For this prototype, the concept uses pulley and belt mechanism to control and operate as a safety tool, which enables the user to freely move around the bar in any direction with only constraints of 2 belts holding it on each side that won't pull the bar unless user fails from holding the bar. The belts are attached to the bar using special hooks and pins implemented on both sides of the bar. The belts are then pulled by a motorized actuator on both sides of the power cage. For workouts that require using lower part of the power cage, such as chest press, the power cage will be equipped with 4 alternative lower level pulleys that the user only needs to hook up the belts to and begin workout.
Design 3 starts with a pair of cables and collar bearings which will be placed on the bar. These are adjustable, allowing for use of different bars and different exercises. The cables extend up over a horizontal bar resting within notches on the top of the cage. This bar can be adjusted before exercise to ensure forces are exerted only in the vertical plane while in use. The cables are also attached to a shaft which is attached to a motor. When activated, this motor will rotate the shaft, winding the cable up and assisting the user in lifting the bar. Advantages of this design are a lightweight and simple design when compared to the other prototypes. Its design allows it not to impede the athlete's movement or force any changes to exercises, and it also allows for unrestricted movement in all directions. Disadvantages are, it requires slight modification to allow for 2 independent motors to raise the bar separately, and it is unable to restrain the bar in all directions when the safety mechanism activates, only stopping its vertical movement.
With this design, the barbell is attached to 4 independent arms. It allows barbell to move in all 3 directions. The attachment on each side can move and freely rotate independently. The main advantage of this system is the safety of the athlete. When he fails lifting weights and accidentally drops it, the system does not restrict the motion of the athlete, and it allows rotation and translation in all 3 directions. With the use of good sensors and motors, this whole system can be implemented, and it can be life-saving for heavy lifters.
After analysing all designs, as a group we decided to recommend design number 3 to our client as our best. Each design had its advantages and disadvantages, and each had areas in need of further investigation after the completion of our project, but we thought that the simple, lightweight and unintrusive design would allow for easy, intuitive use and provide a safe environment for all users. Our final recommendation to our client was that they would be best off using design number 3 as a starting point for any further project. The client seemed pleased with this recommendation, as he had drawn similar conclusions throughout the presentation. However, he was still very focused on eliminating the problems within the design before going any further with it. So, to sum up our project, we took a universal problem of safety and used our own knowledge and the tools and feedback given to us in this subject to brainstorm, ideate and prototype multiple solutions before finally recommending our best design to our client. We learned a lot over the course of this semester, and this project really taught each of us valuable lessons that we will be able to use further in our studies or once we graduate. We would just like to thank all the teaching staff, especially Mark, as well as our client Clyde, for all their help and feedback throughout the semester. We wouldn't have been able to complete this project without you.